Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 5.4 entitled Standard Form. And today we're going to write the equation of a line in standard form when we're given the slope-intercept form. We're also going to write the equation of a line in standard form when we're given just a slope and a point. So we might have to use point-slope form first. And then we're going to write the equation of a line in standard form from just two given points. So standard form is ax plus by equals c. And we've talked about that before. We have to remember that a and b and c are just all numbers. They have to be whole numbers though, no fractions, no decimals, and a has to be positive. That's just one special characteristic of the standard form. Whatever term is in front, whatever term is that lead coefficient, they call it, that has to be positive. Okay, so we're going to be given, for example 1, we're going to be given an equation that's not in standard form, and they want us to put it into standard form. So we're kind of working backwards here, because all of these equations are y equals, y equals, y equals. So these are usually how we like to see the equations. We like to see them as y equals something so that we can graph it. But to get you used to working with the standard form and to get you more and more experienced with solving equations, we want you to practice this process. Okay? Now to put an equation in standard form, remember the a and the x have to be on the same, the x and the y have to be on the same side of the equation. So here I have a y on one side and an x on the other side. So I want to move that x over to be with the y. And the 5 we'll just leave there because he's just my number, c. It just stands for any number. Okay? So that's basically what I'm going to do for all of these. Since they're all in slope-intercept form, I'm going to move that x term over to the side where the y term is. So for part A, I'm going to add x to both sides. Now, standard form has the x coming first and then the y. So I'm going to write it that way. X plus y equals 5. And that's all I need to do for that one. I don't have any fractions or decimals. A is already positive. Now I have the x and the y on both on the same side. So we're done. Okay, now for part B, I'm going to start off the same way. I'm going to take this x term and move it over to the other side. So I'm going to add the 1/2 x. So again, my x term needs to come first, so I'm going to have the 1/2 x plus y. Remember, they're not like terms, so I can't combine them together. Equals 7, because those guys cancel there. Now, I'm almost in official standard form. There's one problem. It's this 1/2. I can't have a fraction in my standard form. So I need to get rid of that. So what number can I multiply everything by so that I get rid of the 1/2? Or what's the smallest number that I can multiply everything by to get rid of that 1/2? And that would be 2. So you basically multiply by the denominator. So then 1/2 times 2 is going to be 1. And then 2 times y will be 2. And 7 times 4 is 14. Now my equation is in standard form. Now, you can do that multiplication step earlier as well. If you see that there's a fraction there in your problem and you want to get rid of it right away, you can do that. So I could have multiplied the whole equation by 2 first and then moved the x to the other side. Okay, so that's just personal preference as to how you want to handle that. Okay, so for part C, I'm going to practice this one more time. I'm going to move the 2/3 over to the other side. This time I have to subtract the 2/3 to move it. So I'm going to have negative 2/3 x plus y equals 4. Now this time I have two problems. I have a fraction and I have a negative. So to get rid of the fraction, I'd have to multiply everything by the denominator. So I'd have to multiply by 3. But I also need to get rid of that negative. So if I took a negative times a negative, that would make it positive. So I'm going to do 2 steps in one here. I'm going to multiply everything by a negative 3, and that will get rid of my fraction and my negative. So 2 over 3 times 3 would just be 2, and then negative times negative is going to be a positive. So I get 2x, and then I have to distribute the negative 3 to the y, and distribute the negative 3 to the 4. Remember, when you're multiplying by this number, everything gets multiplied by that number. So now I have an equation where the x and y are on the same side, the x comes first, there's no fractions, no decimals, and that number in front of the x is positive. Now, standard form is really useful when we're trying to find x and y intercepts. So there is usefulness in standard form, okay? So it's good to know how to get an equation into standard form so that we can work with it when need to. Okay, example 2 says to write in standard form the equation of the line that passes through the given point and has the given slope. Okay, now if I see the words point and slope, right away I should think of point-slope form. So that's how I'm going to start these problems. Once I get it in point-slope form, then I have to rework it so that it's in standard form. I want my final answer in standard form. Okay, so remember, point-slope form is y minus y1 equals m times x minus x1. And then I'm going to distribute the negative 3. So I'll have y plus 5 equals negative 3x plus 9. Now I need to get the x and y together on the same side, and I need to get the numbers all over on to the other side. So I need to add the 3x over. So then I'll have my 3x plus y plus 5 equals 9. But then I also have to subtract the 5 over so that I get just the x and y alone on their side of the equation. So 3x plus y equals 4. So after I did that step, I went over here and wrote the final answer. Okay? So we're going to practice this again now for part B. Again, I have a slope and a point. So I'm going to start with point-slope form. So y minus y1 equals m times x minus x1. I'm going to distribute the 2. So I'll have 2x minus 2. And then I'm going to subtract the 2x over. So I can get the x and the y on the same side. I'm going to write the x term first, just like we were doing in the previous example. And then I have to add the 4 over to the other side so that I have just the x and y on the left side of the equation, and then all my numbers over on the other side of the equation. Now there's one more step I have to do for this problem. I have the x and the y on the same side, and the numbers are on the right side, but I have a negative in front of my 2. So I'm going to have to go through and multiply everything by a negative 1. So I get rid of that negative. That leading term cannot be negative when I'm dealing with standard form. There we go. Now I have the x and y together on the same side. There's no fractions, there's no decimals, and that number in front of the x is positive. Okay, now part C. This one looks pretty nice because there's lots of zeros. Okay, so I still have my slope and I still have my intercept. Now, if you've been thinking here, a slope of 0, there are certain lines that have a slope of 0. Those are going to be horizontal lines. And this point here, this 0, 9, that's a y-intercept. So if you're looking at this information and if you're thinking thoroughly, you might just be able to go right from this information to the answer. If not, though, let's use our point slope form. So I'll have y minus y1 equals m times x minus x1. Now, 0 times anything is going to be 0. So I'll have y minus 9 equals 0x minus 0. Okay, 0x and minus 0, that's just 0. And then I have to add the 9 over to get y by itself. So y has to be on one side and the numbers have to be on the other. Now my x really should be on the other side, but I don't have an x, I have 0x. Okay, so I don't have an x term here, I just have a y term. But again, I don't have any fractions or decimals. The first term isn't negative. Okay, so this is a horizontal line. Okay, y equals 9. If I was to graph that, I'd have to go up to 9 on the y-axis and draw my horizontal line. Okay, so even if you have those special cases like horizontal and vertical lines, this process will still work. Okay, try and be analytical so that you can recognize some of those special cases, but if not, when you substitute the information in and start to solve, you will get the correct answer. Just don't feel like you're doing it wrong. Sometimes students see the 0x minus 0 and they think they're doing something wrong. Okay, you're not. You can still get zeros. Okay, now example 3. We have to write in standard form the equation of the line that passes through the 2 points. So we're going to have to do a little bit of extra work here first before we can use our point slope form. We're going to have to find the slope first. Okay? So we're going to have to use our slope formula where we have x1, y1, and x2, y2. So I'll have negative 5 minus 0 over 0 minus negative 2 is plus 2. So that's going to be negative 5 over 2. So that's my slope. Now if you look at your ordered pairs, before you just go right to point slope form, take a moment and see if any of them just happen to be a y-intercept. Because if they are, we could use slope-intercept form and then solve it so that it's in standard form. And actually, this ordered pair here, this 0, negative 5, that's a y-intercept because the first term is a 0. So I'm going to use slope-intercept form. Y equals mx plus b. Now I still have to write my final answer in standard form. So once I get it into point slope form, then I have to do what we did in example 1, where I have to add the 5/2 x over. So I get the x's and the y's on the same side. So let me finish my work up here. So I'll have 5/2 x plus y equals negative 5. So now I have my x and my y on the same side, but I've got a fraction. So I'm going to have to multiply everything by 2. So that will give me 5x plus 2y equals negative 10. Now my equation's written in standard form. So we are developing quite a lot of knowledge about different methods and different strategies that we can use. We have a lot of tools in our toolbox, so to speak. Okay? So we have to be kind of analytical about our problem-solving process here. Now for part B, I still have to start by finding the slope. So let's see, y2 minus y1 over x2 minus x1. So that's going to be negative 3 over 1. So that's just negative 3 for my slope. I'm going to look at my ordered pairs. Neither of them are an intercept. Neither of them start with a 0. So I just get to pick one of them and use point slope form. So let's just pick the first ordered pair. So y minus 1 equals negative 3 times x minus the 3. And this 3 comes from the 3 in the ordered pair. Okay, this negative 3 was our slope. So I know we have two 3's, but they're coming from different locations. Okay, then I'll have to distribute. So this is like example 2 now. So negative 3x plus 9. I'm going to have to, whoa, what was that? Whoa, oh my goodness. Okay, I don't know why we have that giant blue line across there. Yikes. Okay, got rid of that blue line. Now, let's continue this problem. I have to get all my x's and y's on the left side. So I'm going to have to add the 3x to the left side to do the opposite operation to get him over to the opposite side. And then I have to get all my numbers over to the right side. So I'm going to have to add the 1 over. So I'll have 3x plus y equals 10. I don't have any fractions. I don't have any decimals. That first term is positive. So there's my equation in standard form. So this part B, had a lot more steps. If we're not able to start with slope-intercept form, and we have to start with point-slope form, that can have more steps. Okay? Now for part C, I want you to be a little analytical here. I want you to look at these ordered pairs. It says write the equation of the line that passes through the 2 points. And look carefully at these ordered pairs. Both of them have a 1 for the x value. So if we think of this graphically for just a moment, I'd have to go over 1 and up 6 to plot my first point. And I'd have to go over 1 and down 5 to plot my second point. And there's supposed to be a line that goes through those 2 points. What kind of line is that? The vertical line. And vertical lines are always written as x equals. And in this case, it's going to be x equals whatever that number is. X equals 1. Okay? Now, if you didn't recognize that, you could still work through and find your slope and then put it into point slope form and solve it so that it was in standard form, but you would end up getting just x equals 1. Okay, so part C in example 2 was kind of a special case, and part C in example 3 now has been a special case as well. So we're still going to be seeing lots of those horizontal and vertical lines, just like in our last example here with example 4. So it says write the equation of the line in standard form. Now, when we dealt with our horizontal and our vertical lines in our previous 2 examples, we just wrote the equation of the line. It's still in standard form. Okay? So this equation here for part A, that's a horizontal line, and it's up at 7. So it's just going to be y equals 7. It's going to cross the y-axis. Remember that poem, why am I laid out when I slip and fall? And then the other part of the poem is X marks the spot where I stand up straight and tall. So in part B, we have a line that's standing up straight and tall. So it's a vertical line. So the equation for that is going to be x equals -4 is where we're going through the x-axis. So even when you're writing horizontal and vertical lines, they're still considered to be standard form, even though they're not really the ax plus by equals c format. We could put an x in front of the y, it would just be 0x. And we could put a y behind the x, it would just be 0y. Okay, so you still have the x's and the y's, they just have zeros in front of them. So we take them out of the equation. So anytime you write a horizontal or vertical equation, it's in standard form automatically. Okay, now part C, not horizontal or vertical, so we're going to have some slope here. So it looks like my intercept is at -3. So 0, -3 is going to be my intercept. And right there's a nice neat point. And there's a nice neat point. There's a nice neat point. There's a nice neat point. So to count my slope, looks like my slope is just going to be 1. My slope is going to be 1/1. So when you see lines like this, remember you need to find 2 nice points. Hopefully one of them is an intercept. If not, that's okay, but you need the 2 points to count your slope. Now, since this point is an intercept, I can go right to y equals mx plus b, and then I still have to write the equation of the line in standard form. So now I have to get the x and y on the same side. So I'm going to subtract the 1x over, so the x and y are both on the left side. I'm going to write the x first. Don't forget this little negative with the 3. That -3 is like a -3 now. And then I do have to multiply everything by a negative or -1, so that way I change all the signs. I can't have this lead term being negative, so now I'll have 1x minus 1y equals 3. Or you could just write x minus y equals 3. You don't have to have the 1's in there if you don't want them in there. So you should be getting pretty comfortable now working with graphs and reading information off of a graph. Okay? And remember those steps in the beginning. We have to have 2 points so that we can count the slope. If we don't know the slope, if you know the slope and a point, use point slope form. If you know the slope and the intercept, use slope intercept form. If you don't know the slope, you either have to count it off the graph or you have to use the slope formula. And when you're dealing with horizontal and vertical lines, they're automatically going to be in standard form. So there's a lot of little details now in this section. So definitely practice this homework. A lot of it should seem familiar. Some of it's going to be review of the previous sections, but watch closely and be analytical when you're looking at the problem. Look for lines that have no slope or a slope of 0, so you know if they're horizontal or vertical. Look for ordered pairs that have the same x's or the same y's, so you know if they're horizontal or vertical. But even if you don't notice that, if you go through the process of finding your slope and using point slope form and solving so that it's in standard form, you'll get the correct answer. So work out these problems, and if you have questions, come see me before school.